Hello, everyone. D. Alfred Ostrowski. In this recording, I'm going to be giving a demonstration / tutorial on Solidity Events. I'm going to be working with a very simplified generation of a Solidity event, and I'm going to present two examples from the HardHat command console. First example is going to be showing how to both read and interpret a Solidity transaction log, which contains all of your information that resides on the blockchain after the generation of the event. And the second example is going to be using the on method that's associated with every Solidity smart contract to demonstrate the means of listening for the event and operating it on it in real time. As usual, I am going to be using Amazon EC2, and I am also going to be working directly from my GitHub. So you can follow right along with the associated README install file where I have step-by-step, and you can cut and paste along with me, along with the explanation, and get this up and running in the same fashion that I'm presenting to you now. And the advantage, again, is having the common platform that you have a greater likelihood of not having to deal with administration issues. So let me do the installs of Node.js HardHat, and we can get this going. So I'm going to launch my instance. I use Ubuntu C5, and I'm pretty much default to everything else. Deeper explanation of this on other recordings if you want to go to some of the earlier recordings I did on this topic. Assuming you've generated a PPK key and that you have access to generate a terminal to your instance. I use PuTTY. You don't have to. You can use any other means that you have at your disposal, right? So here I'm going to pull in the IP. And again, I'm going to bring up two terminals. One is going to be for my node for the HardHat to run the personal blockchain, and then the second for the HardHat console. If you have this up and running already, you could just jump ahead a little bit in the recording. This doesn't take too long to set up. And again, the purpose of my approach is to reduce, if not eliminate, any of the extra administration that you may have to go through to get a given example to work. And again, this may be a simplified event, but you can use the same approach to be expanded into any level of event monitoring and log file processing afterwards. It can be used for analytics, testing, and overall just monitoring what's going on with your smart contracts, right? So let me go through the installation here. It's changed a little bit from prior videos. And again, I'm going to try to update as I can. It can be a challenge with everything always moving ahead so quickly. There we go. And I have the reference for the node source distribution that can give you a little more insight of the intricacies of the Unix commands. And I don't want to go down that rabbit hole. Again, we want to learn about Solidity, and we could easily go into the explanations of what's going on in the Unix world. Most unfortunately, with Ubuntu, and to my surprise, the npm installer does not give me a current installation of Node.js. And for that reason, we're going through the node source distribution. Whoops, did that one already. So I've downloaded the distribution, configured it appropriately, and now we're going through the installation. All that's left at this point is the Ethers.js library, and then we can do the HardHat install, load our smart contract, and start touching it from the HardHat console. As usual, the EC5 or the EC2 C5 runs pretty quickly, so we're not going to be sitting here waiting for this very long. Let me create a directory. I'm going to call it test, and this installs Ethers and a few additional libraries we're not going to necessarily be using in this demonstration, but it's no purpose to really separate that, right? Just try to generalize these installs as much as possible. I don't want unique installations for everything. So I'm going to make a test directory here, and I can cd to my directory, do an npx HardHat. We'll download and install at the same time. I'm going to default it to just a JavaScript project and default to the other commands. And load in our smart contract and get up and running. And you've seen the smart contract before if you looked at any other recordings on the site. It's your basic hello world. I'm reading and writing to a string. On the smart contract, I'm also generating an event, and we didn't explore this yet to a fullest degree. And so here we are. So I'm going to create it as hello.sol. I'm using the VI editor. You use whatever editor that you like. I'm not doing a lot of editing, so VI suits me fine just for the cut paste activity. You should have a familiarity with the Solidity. If you don't, please take a look at some of my other videos. The focus again is on the event that's generated here, defined as my event test. That's recording this string variable defined as event output. And the value that I'm setting in as my text is set to the internal public string data point. It's also emitted as an event, right? So two means of storage here. So I'm going to go back to the base directory and bring up my HardHat node. So HardHat started up, looks appropriate. I got my 20 accounts. I'll just leave that up and running. And now I can go to my second string and bring in the console. I'm doing everything from the HardHat console, and I don't have to worry about setting a DNS or working around with my HardHat config as I've done in the past because I'm not creating a decentralized app. So I can do this real quick and dirty. I do an npx HardHat console, and do take note, I set my directory to test. If you don't, it'll try to do a separate install of HardHat. So we don't want that. We just want to bring up the console. We're using the same command. So npx HardHat console, it compiles all my contracts before it brings it up. In this case, I had two contracts. I had the lock.solidity that's included with the distribution, and my contract of interest, hello.sol, and they both compiled successfully, so I'm good to go. I'm going to do a get contract factory now that I'm in the HardHat console. You may have recognized from your deployment script, this allows for access to that contract. And from this point, I can do a deploy. I pass it in a variable CD. And again, the beauty, I can just dump my variables to the output screen and validate that as such. I can play around with my smart contract. In fact, I want to at least once to write something to that transaction log file. I have set, let me just modify it to something a little more amenable to my experiment. Hello, and one thing to point out with the log file, that it's generated as data, so we have to perform a couple extra library calls using Ethers.js to be able to translate it appropriately. So I'm doing analytics, or I'm reading my log files after the fact. It's not going to be very easy to work with if I can't translate the data appropriately. So I just want to point that out to keep that in mind as we go forward. I can also do the get operation here just for its own sake, right? So not that we're really going to do anything with it, right? So test that the contract's working, and you can see it being invoked in the background. So as a quick and dirty experiment, I'm just going to get out of the directory at this point. Why? Because I don't want to play around with environment variables or paths or have an expansive path to grab. I want to grab or physically grab that JSON file that has been generated. So when I did the deployment, it writes this to my artifacts directory, and it creates a hello.json, and I want that. That is my JSON-based definition of my smart contract, and I'm going to use that with Ethers library in conjunction with it to be able to interpret the events and generate human readable information that I can access that's relevant to my interests. So at this point, I'm going to go to the artifacts directory under contracts, and under that is yet another directory that has just been created with my deployment called hello. So this is not to be confused with the Solidity smart contract. This is a directory in and of itself where I have the JSON that's stored. So if you're not familiar with HardHat, that's where it's all going. And I may have not pointed this out in other videos. So I have JSON readable accessible information with the ABI and so forth. And I drilled down to that directory. I could have done it in half a dozen different ways. But to me, I know that I can just immediately read that in, and I don't have to worry about, do I have the right path name or environment file set up? So I'm going to start the console at that point, just for the sake of convenience. And I'm going to want to access the contract, so I'm going to read it in. At this point, I'm using get contract factory. So I'm actually reading in the contract again, but the JSON file that's being generated, if I do a redeploy, which I am going to do, it's going to be the same file, so I don't have to worry about that. But all that information needs to be accessible, okay, if I want to do the post-processing and do it in a way that supports my application, right? So here I'm going to read in a file, and I'm going to define a hello.json, and due to my location, I don't have to worry about the path. I can just read it as hello.json, so it's a lot cleaner at that point. So that's why I went out of the console and I went back in the appropriate point. So I read in hello.json, I did the parse, and I passed in the contract artifact from the output of that parse. So I can take any of the major keys and I can append that and access it as such. And again, I can do this, grab that API and print that directly to the screen. So that was the whole purpose of setting it up. So here I'm going to define an interface, and this is relied upon by the Ethers.js to support the translation of that file. So I take contract artifact, I pass it into interface, and I define that as iFace. Now I'm going to exercise the method from my smart contract. Okay, why? Because now I'm going to have easily accessible to the transaction address. I don't have to go back and I don't have to go to Etherscan or any other means of recording addresses and storing them off the side. So that's why I have a little bit duplication of effort here. So I did an operation and I have that stored as a transaction. Again, I have the data stored there, but it's not easily readable. So I have to go through a couple extra steps to be able to read that appropriately. So I'm going to use the Ethers provider get transaction receipt. I'm going to pass that into the receipt variable, just like this. Ethers provider get transaction with TX hash, and that is including the hash value that is defined right here, right? That's the transaction address. If you go into the Etherscan IO, you see all this information. Again, it's abstracted out a little bit with the web interface. And I'm going to pass that into TX receipt as such. From there, I can access the logs, and I can go into TX receipt logs. I can grab that first log, and I could have multiple logs being generated, and I may have to iterate through that. But again, this is a good starting point. And I have the data there, and it's accessible, but it's not that easy to read right at this point. So for that purpose, I need to use parse log, and that is a method associated with iFace. So that was the purpose of using the iFace. And here I can parse that log, and it will also interpret my data to human readable. I have that information along with any other data that I will want to make an association with that. So including the block information, associated addresses, and so forth. So this is a great starting point, right? To post-process a lot of your events and figure out exactly what happened and get a deeper understanding of how to work with events, generate your analytics, even support your assertion testing on some level, and really understand at a deeper level what your Etherscan IO is doing, right? So these are the operations that are happening behind the scenes. And again, the advantage over a remix will show your events. But again, this is taking us a lot closer. I can cut, paste these examples, put them in, test them out, and then I can easily move them in a straightforward fashion into a decentralized app for greater purpose, right? So that was the first example. Let me get out, and I'm going to show how to use the on method with an event and be able to listen for the same event, except in this case, in real time. And you could perform any type of event-based processing. To do that, I'm just going to back out, and I'm going to go to the base directory here. Once again, just to be consistent more than anything. And I already have the confidence that the contracts are working appropriately. So I'll just go full screen just to clean it up a little bit from the interface here. So here I'm going to pull in a contract again using my try and true get contract factory method. Whoops. Got to bring in the console first. Sorry about that. That was at the console prompt. There we go. There we go. We brought up the console, and we didn't see the compile because it's already compiled. So it already tests that. If it wasn't compiled, it would have got another compile there. But the smart contracts haven't been changed, so it tests that, and if it doesn't need to be compiled, it won't, right? So here I pull in the contract, and I'm going to do a deploy at this point again. CD for contract deployed, and I read in a CD. In this case, I'm going to generate a filter. Now you can have multiple events, and there are multiple events in more industrial strength smart contracts, right? In this case, you are asked to create a filter, and I have my deployed smart contract deployed, and I can call the filters method, and under that I have my event test, and this is the event that I created with my Hello World smart contract, right? That I named it appropriately, and I'm going to pass that into the filter. This could be a transfer event, however you want to filter out your smart contracts, whatever information that you're interested in. Now I'm going to rely on, which is a baked-in method with every smart contract. I'm going to pass in the filter, and I'm going to have info set up as the output and execute any line of code. I'm going to put 3 stars here in front of the info just so it'll be easier to find, because I generate a lot of information when I call the smart contract. So this is going to be setting up effectively a listener in real time for my smart contract, and to be able to do any type of processing based on the specific event that I'm looking for. So I set it up, might have been more appropriate to use a weight, but I'm not really signing anything, so I'm not too worried about the use of weight, and it works as it is. And again, we're not going to be leaving it. This is just a testing point, right? To have a quick and dirty way of testing our operations, and then we can, whoops, and then we can go back in and move this into a decentralized app. So let me do a set. Hello, and I'll put a weight in front of it. Definitely, if I have a DApp, I want to use a weight in front of this. And there you go. It triggered the event. And the reason I know that, or absolutely right, is because I did the set, and it has the contract event payload emitter. But most importantly, it set off that file. If I scroll down a bit here, I have info with the 3 stars. So there you go. That is the console log information that's being set. So I'm both initiating the event and monitoring it from the console. So I have to keep everything in context here, but I have the real-time event listener, and I did the set operation, and it flagged that. And most importantly, with this approach, you have the translated information. So I don't have to go through, as I did with the log files, and do an interpretation of that data variable. I have the result. It's all in JSON-based format, so you can process it any way that you like. So there you have it, 2 ways to test and do a little bit deeper investigation of your Solidity events. And again, everything is directly from my GitHub. You can reference that. Thanks for listening. I hope this helps, and I'll see you on the next one. Thanks.